the data types, we have different data types in Tableau, and every data value will fall into a category of a data type. So each column in your data will be classified into a particular data type. Tableau classifies this data into different data types, and some data values have only text. So their data type will be string. That means it only has characters inside it. And some data values have only numbers, and this data type is called an integer. That means this only has numbers inside that column. If the column is like kind of a format of a date, then the data type would be date. The date type also can be displayed in different formats, but whenever you have this data type as kind of date format, Tableau will recognize it automatically and tag the data type as date for it. So each data type is actually denoted with a different distinct icon. By this, we can actually easily identify the data type inside the column. We'll talk about geographical values first. Geographical values are actually identified by this map icon. The data column would be looking like this icon. We have cluster groups whenever the data is kind of mixed with different data, like let's say it has numbers, like it has string, or it has some special characters inside of it. We call them as cluster data, and the icon would be looking like this. And the third one would be Boolean values. Boolean values are the true or false statements, and the icon attached to it will be looking like this. The inside of the Boolean values will have only two values, either true or false. The fourth one would be numerical values. Numerical values indicate that they only have numbers, and the icon would be looking like a hash mark, and it represents only numbers. The fifth one would be date and time values. The date and time values are allocated to a data type called date format, and this one is the icon displayed. This one actually has date and time in that. That's why you can see a calendar icon and also a time icon attached to it. The sixth one is string values. This is the most common data type we see. Numerical values and the string values are the most common ones we will see. The string values are also called text values, and it is displayed with the icon called ABC. In date values, we also have a date value without the timestamp. So in that case, only the calendar icon would be seen over there, and this is the representation of that icon. We will take a few examples for each data type, and in the Boolean, we only have true or false, and that data type would be looking like this. And date and timestamp values would be like date is coming like this. We still see different formats like month first or date first, but the date calendar icon, and if it also contains the timestamp, it will be looking like this. And we have a date values. The date value would be looking something like that because it doesn't have the time inside it. And geographical values, for example, New York, Paris, India, Japan, these are all geographical values, and they are tagged as a map icon for it. And string, number, or whole number values, this numeric data type values can be either an integer type or a floating type. Most of the numeric values are of integer type because float values, users face difficulty in accumulating the decimal point, as you see here. So most of the time, the integer value will be a complete whole number. However, this float values can also be used in different calculations after rounding them up into the corresponding integers. A function known as round function can be used in this particular scenario for the float values. String values consists of 0 or more characters. that means it has a text data type. This value is considered as string whenever the characters are enclosed inside a double or single quote. So if you're using string, you can actually use this double quote or single quote to fetch them up. For instance, the string data value can be Tableau or Tableau desktop using a double quote for them. You can also incorporate double inverted commas into a string. So in the string, we have a character string type and varchar string type. The character char string type has the values of this data have kind of fixed length. The memory corresponding to this fixed length is allocated to that character char string type values in Tableau. If you try to enter a string value with a length greater than the fixed length, then the system is going to show an error, and this data type generally stores this alphanumeric data values. That is the difference between char and varchar. Varchar type stands for this variable character length, where the length of the characters can be entered into a string as not fixed or predefined. You can enter as many as characters without having any memory allocation restrictions. This string type can also store this alphanumeric values. So that is the major difference between char and varchar. Irrespective of what type of char string type or varchar string type, Tableau will allocate the icon of ABC data type to the string values. We will discuss more about the description part for this data types. Like we will see more into what is the Boolean type and where this Boolean type is used. The Boolean types are actually relational calculations. That means you just have to either select whether it is true or false. We call it as logical values, and sometimes if the relation is not setting up to false or true, the values are displayed as nulls because the calculation is not mapping up to anything related to the true or false. That then it will go to the null part. So Tableau has different formats for this date and type, and there are all kind of formats are accepted for date and type for us, like DDMMYY, DDMMYYYY, that means 4 Ys with a year, or MMDD of 4 Ys, and some fields can only contain a date value, or a date can exist along with a timestamp. The time data values can be a decade or a year or a quarter, month, day, hour, minutes, up to the seconds. We can take any kind of timestamp data values in here. If you also wish to add a data value in the form of string characters, you can add a hash sign before the date, and it will take that as a string character. Tableau registers date and time values under two data types. As you see here, we have two data types for the date times. One is only containing date values, and other is actually containing date and time. And this date and time is useful to show up to the users wherever there is a global difference in the time. Let's say we are updating the data and we are doing it in IST, but whenever we want to show the dashboard to the other people who are in global time, and we wanted to let them know, okay, this dashboard is updated at that particular time, that point of time, and we can actually include the timestamp also saying that, okay, this is updated at that point of time, and it is like very useful to us. Geo values, coming to the geographical values, it also doesn't include like countries. We have also cities, regions, postal codes that will be coming up as this geo tagging, which has this map icon. They all belong this geographical data type, and this field is particularly used in our map visualizations more. Tableau has this a brilliant understanding of where it is tagged by actually bringing up its latitude and longitude also into a view. You don't have to do anything. Tableau will defaultly pick up the geographical value and tag them to each latitude and longitude. Let's say India's latitude and longitude will be picked up according to the column, and when you use that field into your view, it will be like showing that particular point on the map. We have like one more data type called cluster or mixed data type. Sometimes the field might not consist of a single data type. It has a mixture of data types. This is also known as cluster group values or the mixed data values. In these scenarios, you can either handle them manually or such fields will be aggregated values based on the different data types in a column, or you can actually let Tableau handle it how it wanted to pick up the data from. So this is all about our data types, and our next topic would be dimensions and measures. So what is a dimension and what is a measure? So whenever you feed the data into Tableau, whatever columns you have in your Excel sheet or any database or a table, everything will be displayed in your sidebar. Tableau will characterize them into dimensions and measures. Dimensions and measures totally depend upon the data you have in your Excel sheet or whatever data source you have. Each column is considered as a data field. So dimensions are the qualitative values. We can actually consider dates, geographical data, names, all under into dimension values, and this dimension will affect the level of detail. So if you don't understand like how dimensions are going to affect the level of detail, we can actually see that in the software demo, and you will be able to understand what is the difference when you use a new dimension onto the view and how it will change the level of detail, etc. So what is a measure? Measure contains this numeric values, or they are called quantitative values. These measure values are aggregated according to the available content, according to the available data you have inside your data source. This aggregation is automatically applied whenever you use a measure onto your view. So whenever you drag and drop a measure onto the view, Tableau will automatically aggregate the measure. It will first recognize that it is a measure, that it is a number type, and it will aggregate according to the default option available. So we do have two more options in this: continuous and discrete. Continuous means forming an unbroken whole without interruption. That means we are actually in the meaning of the word itself, continuous means it is continuous, and discrete means it is separate and distinct. Let's consider you have a number 1,000. Like you can also show it in 500 and also in 500. But if you have a word, say tableau, and you can't separate it, it is like totally distinct. It's kind of the difference. For an example, we will also see what is a continuous measure, what is a continuous and discrete, more in the coming software demo. So all the green measures are actually dimensions, and if you see this example over here, sum of profit is a measure, but actually an order date is dimension. But if you see some dimension in a green fill, then that would be continuous. Continuous values are considered to be an infinite range, like it is actually continuous, it is infinite. These values adds access to your view. It will, if you drag and drop a green pill onto your view, it will create an access for your view. Blue ones are actually dimensions. They will not create the axis, but they will create the headers for you. So blue measures looks like this. Basically, profit is a number, and it is also aggregated to a sum. That means it is a measure. But if the measure is looking in a blue pill, that means it is a measure, continuous one, like discrete one. Your continuous pill is actually converted to a dimension, and this one is a discrete measure. And this one, the product name is actually a dimension and are discrete. You can consider all the green ones as continuous and all the blue ones as discrete. Green ones are numbers and the blue ones are text values. Discrete values are treated as finite numbers. We will continue to see what is the difference between all this in the software demo and see what are the data types first. Okay. So this is our data which is already loaded into our Tableau, and you can see we have all the columns displayed here. And we also see what is the data type allocated to each and every column. So what is category? Category is coming in ABC and it is also showing in blue. That means category is a string value. We talked about what is a string value, right? So it contains only text values, and if you want to see what is inside that category column, you just have to right click on it. Just right click on your this arrow mark and click on describe. You can see what is this column, what is this row types. It is saying it is discrete dimension, and what is this remote type name, and also whether it has nulls, and it also shows you what is the data inside that particular field. So category contains 3 values inside it, which is furniture, office types, and technology. That means it all only contains the text values. That's why it is a discrete dimension and it is displayed in blue, and it has an icon of ABC. But if you see city over here, it has the geographical icon. That means this one is actually a geographical data type. If you want to look at what kind of data it has inside it, you just have to go to the describe function. You see here, this is also a discrete dimension because this contains the location kind of data. And if you can see, it has 531 members inside. Tableau doesn't show all the values, but it will show the first top some values, and you can see what values it has inside. This all data belongs to location type. That's why you're actually seeing a geographical map icon over here. And if you go for the country is also coming as a map type because this is actually a location, right? And if you see here, customer ID is actually tagged to a text type, and it has alphanumeric values. We already discussed, right? A string value, char and varchar characters are alphanumeric, and whenever we have data like this, Tableau will consider them as text values and will allocate the string data type to it. Next, we are moving to order date. Order date has this calendar icon over here. That means this is a timestamp date format, and if you want to see what it is inside, and you can see the date format is actually coming in date, month, and year format. It has these many values, and it is also a discrete dimension. And if you see here, all the hash marks are coming up here, and because the measures are coming in the green pill, and we call this as a pill, and you can also call them as columns or the field types. This one has only numbers, that's why it is actually showing up in green color. These dimensions and measures are segregated, like they are differentiated with a line. If you can see here, all the green ones are coming down and all the blue ones are on the top of it. And if you just want to see the data inside, you can select on describe. Because this is a continuous measure, it is not displaying the type, the data inside of it, because there is no aggregated value to it, and it will not recognize each row when you click like it. But if you just click that onto the view, you can see it created an axis. That means this is a measure, and this contains number inside it, and how much number of data, like what is the aggregated sum of the profit value. You can see it as 2AX396 Tableau automatically aggregates the data to a default one, which is sum, and it will show the value to the over here from the measures. So sometimes Tableau incorrectly interprets the data field of a time. For example, Tableau might interpret a field that contains dates as an integer data type. Because dates will come in the form of numbers, sometimes Tableau will not consider it as a date and it will tag integer data type to it rather than a date data type. You can change the data type for a field that was part of the original data source on the data source page. Let's see how you will see this data on your data source page, and this is how you see your data on the data source page, and you can also see the data type coming up here. And sometimes, like we said, if the number format here is not recognized as a date, Tableau will allocate a number type over here, but it will not allocate a date type over there. In that case, we can actually change the data type by clicking on the icon here. So this will show the options available in a drop-down list, and you can actually change the data type from a number value to the date type whenever you see there is a difference in the recognition part, like Tableau recognized it wrongly and you have to change the data type to something else. Then you just have to click on the icon over here, and this drop-down will show you what are the options available for that, and you can change it from here. So a small tip over here is whenever you load the data into Tableau, it is always better to actually look at the data type and how Tableau recognized the data type. If the same example, whenever the data is not recognized and it is taking number over there, and accidentally you didn't check and you went for the extract and created the extract of your entire data, it will take that data type also into your extract, and whenever you're working on it, whenever you're pulling the ship date or order date, and if it is in the number format, it will not show you date, it will show only the number. It will also affect your level of detail, and it will also affect the view you're working on. So it is like a better understanding to have with the data you have, and it is always better to check the data types whenever you're loading your data into your sheet and extracting the data from your data source. So this is how you change the data type of your field in the data source page, and there is also an option for you to change the data type inside your view over here. Just say clicking on here will show the same drop down you just saw in the data source page, and you can actually change the data type from here as well. If you want to change the geographical role for any of the maps, also you can change the geographical role from this drop down. Let's say this is now recognized as city, but you want to map that field to something else. You want to map that to some county or some country region. You can actually change from this, but Tableau is so brilliant in recognizing these data types. You will have appropriate data type mapped until unless if the format in your Excel sheet is not proper, and when your data is not structured well, and Tableau will make some mistakes to recognize the data type. But beside that, Tableau will recognize your data type well, and it will tag your data types appropriately according to your data. So there is one more way to change the data type in your view inside. You can go to any column you want to change into, and you see the options over here. There is an option called change data type. You actually see the same drop down over here also. This is one more way to change the data type whenever you want to change it. A simple note to remember in this data types topic: sometimes when your data in your database is more precise than Tableau can model, you will get a warning symbol whenever whenever you use that particular field onto the view, that warning symbol will look like an yellow exclamatory mark in the right side of your status bar here. That means it actually is more precise than Tableau can model, and you can recognize those by that yellow marks coming up over here. So we talked in depth of what data types we have in Tableau and how Tableau can recognize them to a particular data point. On the next topic, we will discuss about dimensions and measures. If you see here, we already have all our dimensions and measures coming up here. All the blue pills coming up over here. These are the dimensions, and the green ones are actually measures. And if you see here, these are the discrete ones, and these are the continuous ones, and you can recognize them easily by the color coding part which Tableau creates automatically. And we will see some fields, possible combinations in these fields, and we will differentiate what is the difference between what. Let's say we have a product name. This one is a complete discrete dimension. That means it is finite, and you can't change it to another measure kind of. You can't change it to continuous, which is completely discrete dimension. And we have discrete measures. Let's take the example of, let's say we took a profit. So profit is basically a measure, and it should be continuous because it has numbers inside it. But if you want to show it in a discrete format, you can change it in this field to discrete, and this will become discrete measure. That means if you see here, it turned into blue. That means it is a dimension now, and it changed to discrete, and this will be displaying like that. Let's see why we are actually changing them to continuous to discrete. I mean, we are seeing numbers, and it is fine in the view. And why do we need this option at all? I will show you why. Okay, let's say I have order date, and let's say I have a profit in my view. And if you see here, we have other options available to actually convert this date into other numbers. I'm just taking the day over here, and what order date become here is a measure. That means it will create an axis for me. See, if you see here, it actually created an axis, and I have to show it in a date format, and this is what I'm intended and to do. So what I'll do, I'll change it to discrete. Then it will my complete view will change it to this. That means I have a discrete in my dimension over here, and we changed from measure continuous to discrete, and the look will be changing it like this. It'll no more create the axis, and it will change it to something like header, and the value will come up like this. So we talked about discrete dimensions and discrete measures. Discrete measure looks something like this. You can change to discrete and continuous in here, and your value will be displayed like this. And we will see what is a continuous dimension and what is a continuous measure, the vice versa of what we talked right now. So continuous measures are actually these are complete number format, and if you see here, the role type is continuous measure. That means this is a number, and this is infinite. It can be continuous like this. And when you drag this continuous measures, they will create an axis, and it will look like this. It will show the axis. Let's take the order date again and see how it looks like when it is in continuous format. Right now it is in discrete. I'm just making into continuous format. See, the view will change to this because my continuous format actually created an axis to me. This is called a continuous dimension because I picked up the dimension and made it to continuous, and it created an axis to me. And how the continuous measures look like are directly coming from here, and these are the continuous measures. See, these two right now are measures. One is a continuous dimension, and one is a continuous measure. Both will create the axis, and you build something look like this. The x-axis and y-axis have numbers over it like this. So if you see here, measures are always aggregated in the view. The default aggregation whenever you pick up a measure onto the view will be sum, and measure is because measure is a continuous format. It will aggregate the value to the sum and display the sum of discount over here. And we do have different aggregations, but the default one is sum. We will talk about aggregations in the coming sessions in the deeper level. So when you doesn't want your measure to aggregate, because Tableau will defaultly aggregate whenever you pick up a measure onto your view. And if you do not want to aggregate your measure, you have to go to analysis and click on this checkbox where it says aggregate measures. And if you click on it, Tableau will take each value from just imagine that you have 0.2 for year 2014 for some date in one particular row. It will take each row and plot your data. That means it did not aggregate the data according to the year. It is showing each and every value from your data onto the view. That's why your view changed from a line like this to a line like this. Basically, the level of detail in your view is determined by the dimensions in the view. We do not have any dimensions over here, but if you just pick up dimensions from here as category or anything, you will see how it is. Okay, so we have a level of detail as category because dimensions actually pick up the level of details in your view and aggregate the data according to that. This is now aggregated according to furniture, office supplies, and also technology. But if you have another dimension in your view, all the data will be aggregated based upon this. Again, it will go to category and it will come up to subcategory, and your data will be aggregated according to the dimensions. In some cases where your data is already aggregated in your data source and that field is picking up in here, let's say the total is already calculated in the Excel sheet and you have a column called total, and that one is coming up here, that will not be aggregated and your total will be shown directly over here. Now we understand the basic concept of what is a dimension and what is a measure and what is a continuous format and what is a discrete format. Let's take some examples to actually see the difference between these. In the example, okay, we will take a quantity in the columns and sales in the row. And in this example, because the quantity field is actually a continuous field, it creates a horizontal axis along the bottom of the view, and this both are continuous fields. So that's why both the x-axis and y-axis is actually showing up the axis for a number, and these are meeting up somewhere, and the view you're seeing is completely both measures. But what if you just make it into dimension? So the quantity right now is a discrete measure. That's why it did not create axis. It actually completely came up into one value, and only the green pill is showing the axis and blue is not showing the axis. That's why you actually see a bar over here. In both the examples, the sales field is actually a continuous field and it creates a vertical axis because this is continuous and it is added to the row. That's why you're seeing a vertical axis over here because that is in the rows. If it is in the column shelf, it would create a horizontal axis. The green background and the aggregation function in the case of sum will help indicate you that the one pill is a measure and the other one is actually a dimension. Let's see how the axis will be when you see that a sum of sales in the column shelf. This is how it looks like, and the axis will be seen like this. In the same way, we will see in dimensions as well. Let's say we have a category in columns. So category is actually a discrete dimension. So this one will create labels for you. In many cases, dimensions area will initially be discrete, and when you add them to the view with a blue background, you can recognize that it is a discrete measure. In some cases, if we have a date dimensions and also the numeric dimensions, let's say take the example of row ID over here. This is showing as it is a number, but it is coming up in blue. That means this is a dimension which is in the numeric format, numeric dimensions. These ones can be either discrete or continuous. If you drag a dimension to rows and columns, you can actually change the field into measures by just clicking on this here, and let's say take some measure, a minimum value or the highest value, and I just took the minimum value, and this one came this one is actually a continuous dimension. So let's make this into a count. This one actually created an axis for us, and it's completely turned into a measure value. Now the view will contain this continuous axis instead of column or row headers, because our background color changed to green. That means this changed to measure, and this will only show axis part. Date dimensions can be discrete or continuous. It can be both. Dimensions which contain strings or Boolean values cannot be continuous. Let's say the example of we do not have the Boolean value over here, but if it is like dimensions continues only the string values, and if it has only the true or false value, they cannot be continuous, because Tableau cannot aggregate these functions, because we used in here in an example category as quantity. This makes no sense, because this is a string value. That means you cannot use it as a continuous version. It will not aggregate your data. These are the cases where you actually count your string values to, if you do not have any measure value associated to that, and if you want to, let's say, how many categories you have, then you want to count them, then you can do a count of the string values, but these dimension values are not continuous, because these are used in the level of detail. That means they are dependent on some other measure. So they will be used as dimensions only, and they are not considered as continuous values. We will see one more example of how these dimensions actually change on level of detail. The level of detail in the view refers to how granular the data is given dimension and the measure data into the view. As you add your data fields to your rows or columns, the number of marks in your view increases. Let's say I'm just adding category. See, you have 3 marks now, and if I add subcategory into my view, the level of detail changed, and I have 17 marks over here now. Like this one will play a major role in actually changing the level of details. We will see in depth into how it is going to change our view by illustrating an example. Okay, let's take a segment in our columns. Now, as you see, we got three marks over here. Just drag region also into our columns. Okay, now we've got 12 marks, because each segment is differentiated into 4. Segment has 3 and these has 4. That means completely it has 12 marks. And just drag shift it onto our rows. Okay, we've got 56 marks left because we have 5 years of data in our sheet, and this completely changed into 56 marks. And because we have three segments, four regions, and also 5 years, it will be calculated like that, and all the combinations will result in this number of marks. Okay, we would continue adding two dimensions to rows and columns and observe the number of total marks continues to increase because dragging a dimension to a location on the marks card, like such as color or size, this will also increase the number of marks, though it will not increase the number of headers on your view, but it also contains that detail in your view, right? Because you are using them in either color or size. That will also affect the number coming up here, and it will show the number of marks increasing. So, for example, if I just drag drag region, right? I just dragged straight to my color. Let's see, we have 487 columns because our state is we have so many states, and each combination of states to the segment, to the year, to the region will create one mark, and that will be multiplied, and you will get 487 marks in this case. If you see, Tableau is showing 5 rows by 12 columns. That means you have 5 rows here, which is the year of ship date, and 12 columns here because we have segment and region in the view. Okay. Because we do not have any structure here, we've only used only dimensions. Let's say we are dragging sales into our view and dragging sales into the text. Okay, what are we saying here? We have like 56 marks. That means we have 5 marks over here, 12 marks over here. That's 5 rows by 12 columns, and what is the sum of measure we are having here will be displayed the complete sum. But if you see, the level of detail is actually segregated by segment and then region and then by year. You will see each number in each cell. Even if you remove one of the dimension from your view, the level of detail will changes and your number will be aggregated based upon the year and segment. Let's undo it and see how it is aggregated based on this three. In some cases, if you add a measure to the view, it will actually increase the number of marks in your view. For example, if I add the same sales onto my rows, I will have this 56 marks, but if I also add profit onto my rows, see my marks increased to 112, but this is not seen as changing the level of detail because we are only adding measures, but we are not adding dimensions. The number of marks in the view is not guaranteed or corresponded to the number you get by multiplying the number of dimension values in each of the dimensions that make up the level of detail. This means even if you add as many as measures into your view, because we only have one particular set of dimensions, your marks will increase, but your level of detail will not increase because you're not adding up the dimensions, but you're adding up the measures. So in most cases, if you add more and more measures to the view, it will increase the marks, but the level of detail will not change. But if you see here, we have sometimes have missing values. That means to the exact view what you're building on. Let's say you have segment, region, and ship date. Some of the numbers will not match, and some marks will not be shown. It will be hidden, and that is a missing values. You can actually pick them up in here and see the missing values. I just clicked on ship date. I did not have any missing values for the scenarios. I'm not seeing any of them. And if you have some missing values like that in any case scenarios, you can actually go with here and show on the missing values here. These missing values are mostly nulls. That means you do not have any matching data with that particular kind of view. That's why Tableau will not consider showing them up in this. It will not affect anything on your view, but you will see some blank spaces whenever you're showing missing values in some particular case scenarios. In this case, your marks will be increased, but your level of detail will not increase. Let's take one more example on how this measures work whenever you change time into discrete. I'm just taking segment onto my rows and sales onto my columns. So sales is a measure and Tableau will defaultly aggregate measures. If I change them into discrete, I'm just showing into a text because our text will show us in a good one. Okay, let's change this to discrete. Okay. What Tableau does here is it changed the value to a discrete portion and it showed header over here. I mean, all the dimensions, discrete portions will show headers, right? So measures will be aggregated and they're spread across the dimensions based on the level detail. But if you change a measure to a discrete portion, it will show headers like this, and still it is a number, right? So measure is a number, so Tableau defaultly aggregates the number, and that's why your header is actually coming up as a value over here. So we talked about discrete and continuous a bit into depth, and we will also see how this discrete and continuous fields will behave in filters. Okay. When you drop let's take this view and let's say when you drop a dimension field onto the filter shelf, Tableau prompts you to choose which members you want to include in that particular point of view. I'm just dragging category is discrete dimension into my filter. So this is how I look when I drag a discrete dimension value into my filter. I will see the values as text values, and I can actually check on some on what to include and what to not. Okay, this is about the dimension. But when you add the date field onto the filter. So this is how a date field will look when you add it into the filter. The result can be a discrete filter or a continuous filter. And you can actually choose between a discrete one or a continuous one over here. You can also see the data that you're selecting in this particular icons. We will talk about this into a deeper level when we are discussing about the filters. But if you drag order date value into the filter, you can also select if you want it to look like a continuous filter or a dimension filter. Okay, what happens when I add continuous measure onto the filter? So these are the values I'm getting because this is a measure. I'm seeing all the data I types as the hash value, and it is coming in green. That means it is a complete continuous measure value, and you can select the aggregation based upon this. So our next case scenario is how a continuous dimension looks like in a filter. So let's say this has a hash mark, that means it is a continuous value and it is a dimension. Let's say how it looks like when you add this onto the filter. You will see the values like this because this is converted into dimension. This is not a date, and you can actually filter the values like this. Sometimes it will also give you a range of values that you can filter on. So this is how they act differently whenever different kinds of fields are dragged into filters. And the last topic in this dimension and measure values will be conversion of a measure into a dimension value and how you can do it. So I'm just taking a sheet and I'm adding sales onto my rows, discount onto my columns. Let's see what is that. And I'm changing my discount into discrete. This will create a part for me. You can drag a measure field from the data pane, but then use it as a dimension in the view like this, and you can convert this into the dimension from here. So right now, this is in the form of discrete, but still this is a measure, and you can see some value over here. But if you want to change your field completely into dimension, you just have to click on here. So see, it is completely went to a dimension, because it is no longer aggregating the value, and it is coming up as a dimension over here. To complete this process, to completely convert into a discrete dimension, you just have to click on discrete value here. Now it is completely changed into discrete dimension. By changing this into a discrete dimension on your view, it will not change the geographical role or data type from your data source. This is only belonging to your view, and you did your changes in here but not here. So this is in particular to this view, and you changed a discrete continuous value into a completely discrete dimension value. And right now this is created into a bucket format of numbering, and sales value is allocated to each bucket. So if you want to change the data type completely in your data as well, you have an option to drag your measures. Just click on shift, click on quantity, drag them. If you see here, Tableau is displaying where are your dimensions ending and where are your measures starting. You can drag that in any of this over here. So discrete is moved to the dimension column. Right now it is showing as a dimension, and if you see here, this changed to discrete dimension by just dragging and dropping that value over there. And if I use this column over here, because before we actually changed that in the view part, but we did not change the actual data type of the discount. And if we change the data type from here, it changes the data type from the completely data point of view. And if you use that field into the view now, this will be a complete discrete dimension, and you can change the data types like that from here as well. Right now, what we did is we changed the discrete into the dimension, right? In the same way, you can actually change the dimension value into a measure value by just doing the same to the measures. See, it actually became measures over here, and if you use this one, this will be aggregated. See the sum of row item. But what if you just use it in like, so if it is in dimension, and I'm just using like and all the members, and it will bring up all the members in that row ID, because it is not aggregating, it is not measure. Row ID is in dimension, that's why it is picking up all the values 1 2 3 4 5 6 like that, and it is not aggregating any of them. But if you do the same in here, like if you just drag to the row ID to the measures, and if you add that here to you, that will aggregate the row ID, and it will show it in the axis like this in the continuous format. So this is all about dimensions and measures, and also discrete and continuous. But let's take one more recap of what is a dimension and what is a measure. Dimensions are text values and or date values and maps, etc. And this will be seen in the upper part of your sidebar, and measure values are discontinuous values, and will contain numbers inside them, and this will be shown in the down part over here. This will be separated by this name, and you can also see a measure name adding up column coming up from Tableau, measure values, to actually differentiate them both. Dimensions will be in blue color and measures will be in green color. This is the major differentiation part whenever you want to know what is what in the view. And if you see here, you can easily differentiate what is dimension and what is measure over here. And we have four types of segregations inside this. We have a continuous measure and a discrete measure. We have a continuous dimension and discrete dimension. We have seen what is the difference between the four and when to use them. And measures will basically create an axis for you, and dimensions will create the header for you. And whenever you convert a measure to a dimension, that dimension will not aggregate the data. So basically, measures will aggregate the data, but dimensions will not aggregate the data. And whenever you're converting them from dimensions to measure, or vice versa, you can see this difference coming up in your view. So that it is really important to know the difference between these, and this can change really big in your view, like wherever you want to measure, use it as a measure. If you're taking a date and if you want to use it as a measure or a dimension, this is playing a really big part in your view. And most of the cases will be related to a date type. Whenever you're converting them into measures or views, I actually personally suggest you that whenever you're changing the dimension to a measure or a measure to a dimension in the data pane, make sure that you will not be using it again, because you will completely changing the data type and it is permanent. But if you want to use it again, but you do not want to change the data type permanently, let's do them in this view part that will be temporary to that particular view. I suggest that you do change in your view so that you can preserve the data type of the field in your data.